Say it again? It should be announcements, yeah. Let me make sure I saved it there. Yes. It says data March 20th, but that March is not capitalized. That will cause some people to slowly lose their minds, so I will fix that. Yes, I made the mistake. So when everybody gets this logged in, I'm glad you made it. Okay, there we go, that's fixed. If you want to copy and paste that entire column that says sex into the next column over, and then it'll be in the right space. We have to code males and females as said males and females. So this makes an extremely boring YouTube video. However, there's a lot of people not here. More people than here last class, but that's okay. Okay, so the last column is the prime. Okay, so in the experiment, we saw two separate primes. I can't play them because they're copyrighted. And so one of the primes was questions. The Kendama Masters, they saw these kids which are psychotically good at kendama-ing. I'm going to make this video bigger because that was a complaint during my intro class. Okay, these guys are super good at kendama-ing. Okay, I have my kendamas in here. My son's kendamas, actually. And so because these guys are so good at kendama-ing, do you think it'll affect the way you feel about your kendama-ing? Ooh, I have three. Okay. My son was actually pretty good at this kind of stuff. And so, well, I'm not very good at it anymore. He's much better at it than I am now. But whenever my son learns how to do something, I also learn how to do something. Because it's fun to challenge him at whatever he does. And he's much better at basketball than I am, but I don't care. I'll still play. So anyway, so one group of subjects, which is group 2, where it says prime, saw people that are very good at a particular skill do this particular task. The other group is group number 1, which is this one, which saw what? No, that's a good kid, sorry. A little kid hit himself in the head with the kendama. Basically, he was terrible at the kendama. I don't know. One of the two saw one of the two. In this code right here, the code, group number 1, not you, group number 1, okay? Group 1 saw the kid, and the kid was not good at the kendama. The other group saw good at the kendama, okay? So this is our primary hypothesis, okay? Our primary hypothesis is very simple. Ready? Wait for it. Loading. Ooh, it's purple. Okay. Zoom out a little bit so it's not quite so obnoxious. The mu for the kid is the same as the mu for the ninja. So technically, the guys that are super good at kendamas are called kendama ninjas. So when you become a kendama ninja, you can do all the tricks. So the reason we have 3 kendamas is we actually have 4, but my son would let me bring his good kendama into school. And actually, the purple one in here is mine. No, he was. I don't know when. He was very good at it. So what you do on the playground at elementary school is you play Ken for Ken. When you play Ken for Ken, is you do a kendama trick, and the person that's playing against you has to do the same trick. If the person cannot do the same trick, he has a letter K. If then you do a trick, and if he can't do the next trick, he gets an E. If you get Ken, K-E-N, you lose your kendama. High stakes kendamas. Now, this one of these, I forget which one it is. It's my blue one, whatever it is in here. We actually bought in Hawaii, wherever it is, in the bag somewhere. Okay, we bought it in Hawaii because everybody in Hawaii was playing with these when we went to Hawaii a couple years ago. Everybody had one. Click, 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 click. Everywhere. Every kid, everywhere had one of these in his hand. So we said, we need one. So we played with it all summer. My son got pretty good at it, and so he brought it to school, and he started playing Ken for Ken. And he ended up getting this one, beating a kid, and getting this one with a red ball. And we found out later that this one cost about $35. It's rubber texturized, it's hyper balanced. I don't know. They were popular, so they were selling them. So, and then the kid who, wasn't this one that he lost, but a kid whose parents didn't have a lot of money, bought him a kendama because they care about his social well-being. And the kid, of course, doesn't know how to play with it, brings it to school, plays Ken for Ken, and loses it in about 6 minutes. Yeah, and so being in the state of fairness at school, they said, okay, no more playing Ken for Ken. Everybody has to give the kendamas that they beat back. Which caused hours of consternation amongst the school children. Whatever. So my son had won 4 or so Ken kendamas in the week prior to said kendama embargo, so he got to keep them. Whatever. Okay, moving on. So it's been great. My wife had to have a full embargo at her school of kendamas. Sorry for the kendama history. So are the kendama ninjas different than the kendama kids? Well, we're not measuring the kendama success. What are we measuring? What's our dependent variable? What are our mu's going to be? Okay. Okay, so age could be, but wait. Those are not, I'm not asking, is the average of males higher for the people who watch the kids compared to the average males who watch? That doesn't make any sense whatsoever. Because when I'm looking at this, I am looking at the measurements. What are the mu's in this experiment? So I asked the same questions each survey. Okay? So remember we did this in the board last time. What are the different elements of depression? Negative mindset, motivation, and feelings of competence, whether you can feel you can do this or not. So the first question is, how would you rate yourself playing on a kendama? Why would I ask this question first? If you choose, I've never seen a kendama before, like Travis, the first thing you ask, what's a kendama? So does that tell me if you have any previous history with this or not? Yeah, so if you are a kendama ninja secretly at home in the dark when no one sees you, click, 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 okay? Because as a college kid, you're like, oh, no, that's a middle school kid thing to do. That's 3rd grade elementary school thing to do. Well, so you're not, if you don't know what a kendama is, can you answer any of these questions very accurately? Not particularly. So the next question is, if I were to give you a kendama right now, how likely you are to play with it? So this is your level of motivation of kendama-ing. Level of motivation. If I were to pick up a kendama, what would you be able to, if you were to pick up a kendama, what would be your probability of success? If you know nothing about the kendamas, what would you say? 0 or low scores, probability of success, I don't even know what it is. Some people have lots of confidence, 10. What is it? I don't know, but I'm awesome. So we can look at that. We have that data because we have a measurement of how likely you are to be successful, motivation to try. Okay? Then all of a sudden we have, if you were to pick up a kendama, what would you, would you be willing to use a kendama in front of class? Okay, so it's kind of funny. I have a couple students, I was kind of eavesdropping when they were doing the test. I have a couple students that are very extroverted. If you are very extroverted, in my class yesterday, who's the only person that picked it up to play with the kendama? Taylor, I'll do anything. I don't care. I'm a 98% extrovert. It doesn't matter to me. But Taylor happened to be a cheerleader for the last 12 years. She is extrovert. So as a result, she does not have any problems getting up in front of people and dancing and doing whatever. Red, go black, go black. That was San Diego State's favorite cheer. Go red, what's your other color? I forget. We would mimic the cheerleaders quite a lot as the athletic teams, but that's not important, it's not polite. Moving on. Okay. So I have level of motivation prior to seeing video. After you see said video, do you know what a kendama is? So some people will change their answers. So what is our primary dependent variable in this experiment? So our dependent variable, now we only asked that question once. Okay, that's an important question. That's something called a confound or an artifact in this experiment. We have to make sure if nobody knows what kendamas are, our experiment is complete crap. Sample frame. Okay, so we'll just take that into consideration. Okay, our dependent variable is change. Cool. I should make it isosceles. Okay. Change in motivation. So we have a motivation question. If I were to give you kendama after watching this video, how likely you are to play with it? I asked you, if I give you a kendama in the previous page, how likely you are to play with it. So the difference between the two questions is your change in motivation. Change in motivation. So how do I calculate a change in motivation? How do I calculate change in anything? So how do I know if I've lost weight? If I stand on a scale, it's not going to tell me if I lost weight. It's going to tell me how much I weigh. Subtract one from the other. I subtract now minus then. What is that going to be? Dang it, close. Change. It's going to be my delta. It's going to be my change. And so anytime we measure something, if we measure it again, we can measure change. So we can measure a change in motivation. We have three variables that we can measure change in. My variable view, so we look at the data, look at the actual data here. This is just too small for me to see without my glasses, but SPSS won't let me zoom in on it. Okay, so what's the first change variable we have to calculate? You notice that this is exactly the same question asked almost twice? It's almost as if we did the same question twice. I weighed myself twice. That's it though, never stepping on the scale again. But it sits there right by where I put my stuff down at the gym and I just look at it. No, I walk away. Okay, so how do I calculate a change variable? First SPSS step. We did this a long time ago. Transform, compute. Remember doing this? Vaguely. Okay, some of you will get into the problem of you cannot have a space. You cannot start it with a number and you cannot have a space at the end. If it does, it says illegal operation and doesn't tell you why. So what did I label this as? Motivation change, because it's going to be transform, compute. Oops. All right then. Question 1A minus question 1. That's why I labeled them that way, so it makes it easy. You learn that when you enter data in the computer to label variables so they make sense. I'm going to figure out how to make companies stop taking money out of our account. Our cable bill just went through, and then this went through, and then that went through. Stop taking money out of our account. Yeah. Question 1A is after watching the video. Yeah. So if I make this little box bigger like I always tell you to do and I didn't do it, it's right here. You can also just type Q1A minus Q1. I'm going to click paste. I'm going to click paste. I'll tell you why. We're going to be adding more data to this data set. So do I want to click and do all this again tomorrow? No. So this is what's called the syntax. The syntax is, well, what does it say I'm doing here? Airplane mode on. That's not what I wanted. Airplane mode off. Okay. Let's try that one. Okay. So what is this syntax telling me that I'm doing? So this basically says this is the data set. This tells me what I'm using. Okay? This tells me the menu item that I chose, which is compute, and I name the new variable. And then I put the variables that the mathematical concept that I'm going to do. So can I go back and actually do the next one without having to click? Can I just do the next one? Yeah. So what I'm going to do is I'm really too lazy to type everything, so I'm just going to copy this and hit paste. And now I'm going to I don't want to calculate motivation change. I'm going to call the new variable, I forget what the question was. I'm going to look back. Hold on, wait. Yeah. Did you have the variable name proper? Does it have a space in it somewhere? It should not have a space in it. I will come back and look in just a second. Well, I wanted people to try this because in your future life, when you have to do this again, this makes you a very happy person if you learn how to do this now. Okay, so let me come back and see why there's not anything. Okay, yeah, that's why you have too many spaces. You got it. All right. So I am going to print screen this one. So what did I just do here? Now, if you want to do the third one and you know what we're doing, go for it. You have to look at it. Okay. Be more specific. Okay, so we'll see that. Okay, so you're okay, so okay. We'll go back to this one next. And then okay. Okay, so now all you have to do is yeah, what you do is change it. So this is the that is that's the syntax. So it puts the syntax on it. For some reason it's not it should change color. Okay, so what you have to do is you paste it again. Okay, now change the word motivation to success. So what I'm telling the computer to do, is it says I'm going to compute this variable name success change, okay, equals question 2a, which is the same question after the video, minus the question before. So what does a negative number here mean? You have less confidence after watching the video. If there's a positive number, you have more confidence after the video. So the numbers have a range, a negative and a positive, but the average is what we're interested in. And so the negatives and positives will mean something relative to this. Yeah. Is it Q? Is that the, oh, so it should be Q2? Oh, goody, goody, goody. Thank you for noticing that. I thought I set it up smart, and I was proud of myself for setting it up smart. But you're right. It should be question 2. So check this out. I can't zoom in on that. Should I change the variable names to make it easier? Now, then you'd have to do it. So it's super easy with the syntax if I screwed up, because what do I have to go back and do? I just have to go and change this to a 2. Change this to a 3. I'm good. See how nice the syntax is? Come on, did you see what I screwed up? Okay. So that is, so what do we want to name the third one? That's the third level of depression that we came up with. Let me go back and survey and read it. Would you be willing to use kendama in front of class? I would say social. Social change. Oh, I can't, it's too small, I can barely see it, so that's why I'm struggling a little bit. And I can't zoom it in, so. Question 4. Nope. Nope. As long as there's no space in the variable name. So I'll just go back here. We get rid of this one now because that's irrelevant. Hit paste. Got rid of that one, and then let's put this one up here. So now, I really want to get, Dell makes a full one of these. Like a full computer size one of these. Like a tablet like this, so you can write on it and you can do this with the whole computer. But it's a full Windows computer. It's like $3,000 though. I don't really want to spend that. I don't want to spend any money on a computer. So, okay, moving on. So now what I'm telling the computer to do, and thank you for pointing that out because we would have carried on aimlessly without even noticing. Okay, so what the computer is telling me to do, or I'm telling the computer to do, is create these 3 variables. And once I create these 3 variables, then we can make some graphs. Right off the bat, make some graphs. And once we make some graphs, then we have to look at some other questions, like question number 1. Question number 1 is really important, but we're going to just look at it first before we look at question number 1. Okay? So in order to do this, there's this little green arrow up here. What you do is you highlight everything. It doesn't work. I don't know why this won't go away. But, okay, this little green arrow here, highlight everything and hit the green arrow. It's like the old play button on a tape recorder. Tape recorder is the way old people listen to music. Okay, we'll put it back to here. Where's my syntax window? Here we go. So I'm going to highlight everything like this. Shoop. And I'm going to hit the little play button. And what is it going to do? It tells me I just did it. Yay. If it says error and a bunch of things, does it say that? No, it's fine. Good. So the reason, this is actually, if you care, back when we used to use this in graduate school, we had to type this and send it off to a computer. We didn't get to see the data. Yeah, it's kind of cool. Anyway. How different? Oh, you need to be on the syntax window. This one? Yeah, you were in the output window. All right. Okay. So, I can't just send this to you quickly, otherwise I could just dump it on your screen. Okay, yeah. Okay, so now, I'm going to go back to my SPSS, and what should I have down at the bottom? Now, what should you have if you did it right? Yeah, you should. So what I'm gonna write a description now to tell myself what these are. So you have to add it. You can just do the compute statement and click if that makes you happier, or you can do the actual just type it into the syntax, whatever is easier. So far, only 3 students volunteered to play with the kendama in front of class. So far, overall, yeah. No, but if are you kendama skilled? Maybe. You're Asian. So I will gender type you because the last 6 world champions. Yeah, I might have some skills in my back pocket. I'm not playing Ken for Ken with you, that's all I'm saying. Okay. Social change. Why am I putting words that mean what I did? It's not to be thorough. It's so when you make a graph, what is it going to say on the graph? That. So you want whatever you want. If you leave it blank, the graph will just say motivation underscore change, and have no reason what it means. I know it's very exciting. Oh, you have a bunch of blank ones? Yeah, I just deleted those, but you can delete those if you want. But they're just whenever you import a file from Excel, I just do it automatically, so I didn't even think about it. But when you import a file from Excel, it automatically puts a bunch of empty space in there. Yeah, it's just var001. It puts the whole page in there. You can delete it or just leave it there. The computer will filter it out. You don't have to worry about it. Okay, are you ready? This is exciting. Are you guys ready? So I made the joke yesterday we were talking about research careers in my method in the careers class is that this is the highlight of doing research right here. It's like you want to make the graph. Do it! Okay, so before we can start making graphs, what do we have to do? Before I can make a graph, I have to check one thing. What? Okay, so I could make my histograms, but that's not the first thing that you do. It's very similar to a histogram, except it's with categorical variables. It's before you can make graphs, what do you have to check? Look at the descriptive statistics. Who is in this experiment? That'll determine what graphs we can make. So how do I figure out the who's? We don't need to do crosstabs yet, but how do I figure out the who's? Let's write down the hypotheses. It's small again. Why is that? Why are all 3 pens selected? I don't understand. Try to go back and back. Okay. They're still all selected. Weird. Okay. Go small. Go away. There you go. Okay. So what are my 3 hypotheses here? Here's my dependent variable. We have change in motivation. So I'm going to write this out nice and big. I'd like to change color, but oh, it did. Yay. Okay. So what's my null hypothesis for motivation? Wait a second. So that's a different, we'll ask that question later. That's an artifact question. But what I have, what is it? My primary dependent variable is a change in motivation. Ooh, nice. Okay? So what do I have to test? What is my hypothesis that I'm testing? I wrote this back here a second ago, but I wanted to write it again. Is the mu of change in motivation for the kid the same as the mu for the motivation of the ninja? So I'm going to change this. I'm going to change the K and an N to a group 1 and a group 2, because that's how they're coded in SPSS. So how many bars are going to be on this graph when I make this graph? 2 bars on the graph. You're all excited. Bated breath, I can tell. Okay. So now, before I can do this, what do I need to know? What information do I need to know before I can make this graph? Well, the nice part about using a Google form is that the data goes in the right column. I didn't screw that part up. Almost. I fixed it. Moving on. Okay. What do we need to know, though? What groups? Not yet. That's later. Before I can even know if someone has used a condom or not. This is the Captain Obvious question that is the most easy question to answer. Yes, but you didn't say it correctly. How do I know if I have enough people? In what? Each group. So how do I find out if I have enough people in each group? How do I find out if there's 15 in each? I'm going to make a freaking pie chart. Sorry. I'm going to double click on significant pie chart. And my computer doesn't like double clicking from the mouse. From the screen. There you go. I don't want percentages, sir. The fact that you have to ask that makes me sad and hurts me inside. Not really, actually, but okay. What did I have to put in there to answer this question? Prime. Group. In other words, what the heck does number 1 mean? What the heck does number 2 mean? Do I have enough people to even test this hypothesis? I have how many people in one group? 15. How many people in the second group? 20. Therefore, I have enough people. You can handle millions of subjects, but you can't handle 30. Did you figure it out? Yes, but you're quiet. You be louder. No, I'm going to be quiet. I'm not coughing anymore, so I don't have to make a space. It's your virtual. Okay. So ready? Yeah. Okay, of course. Okay. So this is being recorded right now, so it'll be on my YouTube channel. So I'll post a link to the YouTube channel. Because it's the most exciting thing to watch ever. Yeah. Make sure you're here Friday, though, because we're taking a little midterm, which I did not broadcast. Okay, except right now on YouTube, because that's irrelevant. Okay. Hold it. Not this class. Our research methods class is taking a midterm on Friday. You're not in my research methods class. You've caused me to think for a second. Wait. No. We just took a midterm. We don't have to take one for another while. Okay, so now. What if, folks, what about males and females? Do we have enough males and females to test males and femaleness differences? Let's check. That's the right answer. Thank you for not just saying yes. I don't know. Let me look at the statistics. Finally, week 6. We get it. It's actually week 7. That's not important. Okay. Okay, so you'll notice that it's gender because sex is not coded. You have to, but you can make a pie chart of a text variable, no problem. Let me look. Well, it's close. That's actually not bad for psychology. We'll talk about that in a few seconds when we try to make the. You'll see. Okay. What error did it make? Oh, she made it on sex. And there's no people in the sex column. Yeah, but so. It sounds weird. Perfect. Ema. Okay. That's what it says. All right. Yeah, Federal Emergency Management Agency. Okie dokies. So now, yeah, so if you came in a little bit late, I accidentally put the group, the priming variable into the sex column. Sorry. Okay, so when I look at this, when I look at my graph, I have 14 and 21. We could actually run hypothesis of males versus females. Could we use male versus female in different prime? Could I run a group? Can I run this test if I want to look at, I gave the analogy last class for those that were here, is that when we went to the beach, there's a bicycle called a penny farthing. A penny farthing is a ridiculously tall bike. In fact, I could probably find this. Let's see if I can just find somebody. He's trying to be cool on his little penny farthing. It's a ridiculous looking bicycle. Sadly, they're called bone shakers for a reason. So back somewhere online, there's actually is the video of this. But one of my buddies rides one of these because he's an old idiot, and he wears like a tweed jacket and has a handlebar mustache. It's a full idiot level 7, upgraded. But then he tries to get people to try and ride it because it's extremely difficult to ride. So of course, all of us on our bike ride decided to try and ride it. And so guy after guy was falling over the handlebars. I was third, and crashing and hurting themselves. I hyperextended my knee. Anyway, one after another was crashing and hurting himself. The women are looking at each other going, you notice how no women are stepping up to do this? And all the guys are like, I can do it. And all the girls are like, I just saw 7 people fall and hurt themselves. I'm not going to try it. And so that brought this, that's why we asked gender, because maybe gender has something to do with the ability to try or ability to fail. And if you see someone fail, does that increase males' likelihood of trying? Or if you see someone being successful, does that increase females' likelihood to try? So can we ask that question with this data as we have it now? Well, no, don't say that. You have to do what? Let me look at the statistics. We have the parameter, well, we have the ability to, but should we? That's a better question. So I'm going to make exactly the same graph that I just did, except now I'm going to check my sample frame. And this is one of the questions that the method students are going to have is, can we ask this question? And the ones that don't understand sample frame will say yes. And the ones that don't, so this is what I'm going to do. So how many groups do I need now? Okay, so I'm going to write the hypothesis up here. The hypothesis is going to, you can't just write it this way. You have to write male, female, kid, ninja. Okay? That's a terrible box, but it's okay. I can move this line. Okay. So now I'll move the up. Whoa. Whoa. Craziness. One of these days I'll figure out how to use this. Here's my left hand. That'll work better. Nope. There it is. Okay, fine. So now, how many people do I need in each group? I need 15 in each group. So my total N is now has to be not just 45, but 70 at least. So now if I make this graph, Come on, computer. You can do it. I promise. There you go. And I'll... This touchscreen in SPSS is going to really kill me. Okay. So I have 8 and 12 and 6 and 9. So I can't run this analysis because I can run the initial analysis. I can compare males and females. I can compare prime and no prime, but I can't combine them together because I don't have enough people. However, if I add one more section of intro, where should I add people? You can easily figure this out. No, if I just randomly add all of them, the proportions will be the same. So I need to add, mostly I need males watching the males watching the Kendama Masters and females watching the Kendama Masters. That's where my first group is going to be. Once I fill up those into 15, then I'm going to collect some males in the Kid Fail, and lastly, I'm going to get some females in the other group. So I'm going to try to fill the other groups up so there's 15 in each group so we have enough data for tomorrow, or Friday. Because I have a class of about 45 students tomorrow, can I fill the rest of these in? Yeah, it was kind of nice. While the students were taking their test in my intro class, I just passed around this tablet, and students came up to the front of the room. The students that got my tablet got the one prime, the students that came up to the front of the room got the other prime. And I was able to count how many students each I got. Perfect. Okay. Now, we can make the graphs. So let's look. We have very simple, how many bars are going to be? What's my variable on the bars? No, that's the categories. What's the variable that the bars represent? Change in motivation. Good, that was subtle. Okay. Okay, so I'm going to go to graph. And I'm going to go to error bar. We'll show you how to do what's called a t-test in just a minute. Very exciting. Simple because we only can look at one variable. Okay? And what's my variable I just said? What's my mu? Motivation change. Motivation change. And what's my category? What do my numbers 1 and 2 represent? Prime. We don't have male and female coded yet because we don't need to. We're not going to do the male-female analysis yet. Don't have enough data. Oh. Yeah. That means that, okay, so let's see what this means. Okay, I like doing this because this is what doing statistics is all about. We have an experiment, we do an experiment, we design the experiment, we run the experiment, we collect lots of subjects, and we look at the error bar graphs and we see that our means are this. Okay, so what have we found? So if the means are the same, let me go back to my hypothesis. Do we accept this or reject this null hypothesis? Well, actually, technically, we don't accept a null hypothesis. We fail to reject it. Seriously. You don't, because you don't accept, you fail to reject. Yeah, it's semantics, but that's the way we roll in stats. Okay, so basically, we're saying right now that motivation doesn't change watching these people. Oh, she had the Q1 still in there? Oh. That would be interesting to see if that was a difference, but there probably is a difference with that, but not important. Yeah. What does it say? You forgot, because you came in possibly late, you didn't move the data from the sex column into the prime column. So go over to the raw data. So take and so when you made the graph, you chose the prime column? Walking. Oh. Okay, now do the air run. Move over, let me go. Yeah, so not the standard deviation. Hold on. Okay, so let me write this up here, what this means. That's a great question. I'm glad you asked that. So I'm going to take this little thing here and I hit copy. I'm going to post it over here. I'm going to scroll over here. I'm going to hit paste, and it's going to paste in. It does. Yay. Okay. Okay, so I'm going to, this is kind of fun. What this means, I'm going to turn this error bar graph sideways. Okay, and I never can get it to line up just perfectly because I'm not that way. Yes! Okay, so what this is a normal distribution. Okay? This is a normal distribution. It's a distribution of means. Because what does the dot represent? The mean. So this represents a sample of multiple means drawn out of this population. We did this last class as I took the height and I drew a population out. I don't want to talk to this person from Georgia. Hello?
We offer affordable health insurance.
They offer affordable health insurance. Prices that me and my family can't afford. Hold on, my phone is going to block them. Thank you, phone. Okay, so, hey Google, thanks for blocking my spam. He is okay. So now, it will once it learns. Well, if I use Google Voice, if they get my Google Voice phone number, it screens the calls, and if it's a robot, it automatically kicks them out. Which actually is a problem because I have a robot calling from our dentist, but they also text, so it's okay. Anyway, getting back. So what this represents is the mean. So this is a distribution of mean. So this right here is 95% of the possible scores around this mean. So it's based on a number like standard deviation, except it's not a standard deviation. It's the sigma divided by the square root of n, which represents the distribution of means. Okay, so again, I'm not expecting you to understand why it's sigma divided by the square root of n. That's for math to yell at you and force into your head. What I want you to realize though is that between the low and the high mark on this, what we're actually seeing is this is 95% of the people are here. So when I look at the group 1 that saw the kid that hit himself in the head, the average change was +1. So everybody thought that they could do it a little bit better after watching the kid fail. But then, after watching this Kendama Ninjas, what did people think? They could also do it a little bit better. Ew. But there's something that's interesting here. What is the range here? What is the shape of the distribution here? Ooh, that was good. Well, how do we describe larger? We say the belly of the curve is bigger, but how else can you say it? It's plateau-kurtic. So the plateau kurtosis could be caused because of the way that we calculate this It could be caused by the n. If there's a small n, what happens to my error bars? They get bigger. When we have 727,000 people in each group, woo, remember we made some of those graphs and it was just a dot with a line in it? Because the error bar is so small, the error bars don't transcend the width of the dot. That's why when you have SAMP data that has 700,000 subjects in it, everything is statistically different. That's why we kind of ignore statistical differences when we look at things with hundreds of thousands of people in it. It's like one of the California director of education a couple years ago was basically saying, oh, look, standardized test scores are going up. And the statistician raised their hand and says, you have 300,000 subjects in your sample size. The real differences are 0.2 on test scores. She goes, no, but they're statistically significant. And the statistician just put his hand down. Because it's like, there's no point in arguing. 60% of the time, it works every time. Okay, so now, but if I turn this back sideways how we're supposed to look at it, turn it back sideways how we're supposed to look at it, okay? So all of a sudden, now we see two error bars. Could we ask the question, are males more confident than females with this? Yeah, because we have enough males, almost enough males, and just males and females. If there's no difference in prime, can we look at males versus females? The only problem is males and females are not coded as numbers, they're coded as words. So let's kind of ignore that for just a couple seconds. So what do you think might cause your kendama success other than watching the video? Oh, we've got two more graphs to make. I'm sorry. We have two more hypotheses. So sorry, extra hypotheses. What's my next hypothesis I have to write? Make this smaller. How do you make these smaller? Smaller. Shh. Fine. Go away. Go over there. Shoo. Go over there. Okay. Okay, so we have to look at, whoa, that got really small. Okay. My second hypothesis I have to test. Again, second hypothesis, it looks exactly the same, but what's my second mu? It's not change in motivation, but change in success. Oh, I didn't get the box that time. Okay, so can I do the same thing again? Yeah, so I'm going to go to graph. We're actually right now doing this backwards. You make the graphs after you run the analysis. We're learning how to do the graphs first, then the analysis. When I show you how to do the analysis in about 12 minutes, we're going to take a break in 5 minutes. But when we get back to the break, I'm going to show you how to do the analysis. It takes one analysis to answer all the questions that you have about the data. One little syntax, and it does everything. And then you make the graphs of things that are interesting. I'm using backwards chaining, just in case you care. And did they laugh when I shut the lights off? Yeah. Okay, good. Okay, good. Okay. All right. There's much better ways to shape professors than that, by the way. It's fun. Okay. Scroll, graph, scroll. Woo! But statistically, that might be different enough. But that's why the bars aren't the best way to look at it. So what percentage overlaps? I can't draw on that part. Hold on, it's math. I'm just gonna make this zoom in so it doesn't take up tons of space. Okay? I really like the software. Okay. A little sleepy. You're biting it, I can see it. Okay. See, I just got all excited when I saw this, and you're like, okay, I don't care. Okay. So what I just drew was the percentage of overlap, right? So there's a bunch of people in this group that are higher than a bunch of people in this group. You see that? So what we have to find out is this is what we're gonna learn in the next couple weeks in the semester after spring break. Yay! Is that we're gonna calculate the percentage of people who are not overlapping, because all these people, they're the same. Okay, they're the same. They have scores that are the same. But what's different about this graph versus the other one is that in the other graph, almost everybody was the same. Now, what are we finding? So we can't know this hypothesis right off the bat now. The second hypothesis is going to be a question mark, because what else could be true? Maybe mu1 is different than mu2. We're going to have to actually test the probability. We're going to test the probability, called the t-test. Let's do the third one. Then we're going to do all 3 t-tests at the same time. Okay, so what's my third one? Social change. That's the same one we just saw. There we go. And what do you think? Pretty damn the same. In fact, look at these social changes, almost 0. In other words, introverts will be introverts. Extroverts will be extroverts. Wow. But what did change? Well, let's find out. Okay, let's take a break, and then we'll find out. Rendering. Whenever we're doing the SPSS stuff, as from this point forward, I'm going to be recording what I'm doing on here. I like to stand up and walk around a lot more than sit down, but this classroom doesn't facilitate that with my computer. Anyway, so what we're going to do is we're going to run a bunch of t-tests. Okay? A t-test, I'm going to write this over here. Okay, a t-test is very simply, it's like a z-score. Okay, I'm going to write a z-score down below. How do I calculate a z-score? Right. And that tells you the probability of a score being somewhere on the distribution. Wherever the x minus the mean value is, the standard deviation is the average. So this is your difference, or measured difference, compared to the average difference. Okay? Your difference compared to the average difference. A t-test is group 1 minus group 2 compared to the average difference. We'll explain how to calculate this S-diff a little bit later in the semester once we've gone through a couple other types of tests. But what we basically can do is this right here is saying, is the difference between the means, wait a second, I just drew this. Is the difference between the means, come on, you can zoom in, it's okay, I'm okay, you're okay, there you go. Which is greater? How the means are the same or how the means are different? That's the answer. So I could actually go on with my little ruler here and I can measure the amount of difference it has compared to the amount of same it has. That's x minus the mean, difference. Okay, so we're looking at the difference between the two means. Okay, but it gets really complicated with the math. Go away, Mr. Ruler and Mrs. Ruler. I didn't really type you very much there. Okay, so as we go through this, we're going to do these t-tests. T-tests are super simple. Because they're always between two groups. Notice that there's only two means. So when you have a hypothesis that looks like this, you always do t-tests. How many degrees of freedom of groups are there? Degrees of freedom equals n minus 1. So how many degrees of freedom of group are there? 1 degree of freedom of group. Because there's 2 groups, minus 1 is 1. Okay? So whenever you have a degree of freedom of group of 1, you always run a t-test. Always run a t-test. And the reason is it's the best test to use for 2 groups. Okay? Unless you run regressions, but that's later in the semester, don't worry about it. Okay, moving on. So now, so where do I find t-tests? Hey, analyze, because I want to analyze some data. And what am I comparing? Survival. No. What am I comparing? Means. Compare means. Okay, no, it's not a 1 sample t-test. Okay, so let me explain what some of these are to you. A 1 sample t-test is when you're comparing a known score against a known parameter. A known score means, so like if I wanted to find out, is there any change after watching videos overall? Is there a change between before and after? What should the change be if there is no change? 0. So my paired sample t-test, if I'm using, 1 sample, my null hypothesis looks like this. Delta mu equals 0. So in other words, my change in mu equals 0. You use this when you are testing a known parameter. Something that you know what the population mean is. You won't ever use these. Just saying. In social science research, we don't use these very often. Because we can also do, if you look back here, analyze, compare means, we can also do independent sample t-tests. That's the one we're going to do. We're going to compare group 1 to group 2. Are they the same people or different people? Different people. They're different people. Okay? So, independent sample t-test. I'm going to write a letter to SPSS and say, please, can you make it work with my touchscreen? Thank you. And they're going to say, no. And I'm going to say, okay. Okay. Because I really can't, it's the industry standard and it's really frustrating. So what are the 3 variables I'm interested in testing? Yay, my change variables. And I'm going to highlight them all and put them in there. Or click them in one at a time. Super easy. Okay? It's going to be, but we're going to put some more variables in here next. Okay, so now, here's a nice thing about a t-test. Once we set it up, we can put whatever the heck we want in the test variable. So how would you rate yourself with a kendama? We can put that in there to see if there's a difference between the number of people who rate themselves kendamas high or low in each group. Because what if we find out that people in group 2 rate themselves as really good at kendamas? Maybe that could be the reason of success differences if we find any. This is a way to look for what's called artifacts or confounds. So what other question is not addressed? Did you find this video hard to watch? A lot of students with the kids struggling with the kendama will see if they find it hard to watch. When you watch somebody struggle with something, it's kind of like, ooh, cringy. Yeah, that's a lot of people stop watching it. Okay. Okay, so that's it. So now what is my grouping variable? What are the categories? Prime. Prim, actually, is in here, but... So see where it says 2 question marks? So what do those 2 question marks need to be? 2 groups. Define groups. Group 1 is 1. Group 2 is 2. Sometimes you code variables 0 and 1. If we were doing a t-test on drinking tons of milk versus drinking a little milk, we would say 1 versus group 7. We could do a t-test comparing those 2 different groups of a 7 category variable. You can take any 2 variables and stick them together, or two levels of a particular variable. It's nice because I only chose two levels because so we have enough degrees of freedom so we can do the experiment, blah, blah, blah. Okay. Continue. Okay, so go over to options. And there's no plots on this one. Okay, so on the next test that we learn how to do, one of my students showed me how to make graphs automatically on any significant results. They figured it out. I'm like, oh, that is so cool. And so Katie actually showed it a couple of my students. The student showed me, which was awesome. So click OK. And I will... Is somebody just from the house screaming? Happens a lot in this building. It's never. Okay, so I'm going to go back here and I'm going to paste this little chart here. Oh, that doesn't work at all. I'm not going to do that. Okay. Okay, so let's look at this little chart here. Oh, come on now. Okay, so what this little chart is, which is too small for me to see on the computer, so I'll point up here and you can't really talk on this video. So, here's the Kidsdale Kendama Master. It shows me my N for each one. It shows me the average for each one. It shows me the standard deviation for each one. And it shows me my standard error of the mean. In other words, standard deviation divided by the square root of n. Beautiful. Okay, fine. So if you wanted to make error bar graphs with your own graphing software, this little first table is all you need. This little first table, if you want to say, you rate yourself for playing with the kendama. People who watched the kids fail rated themselves as what was their average rating. .6. My students don't rate themselves playing with the kendama very well at all. It's a scale of 0 to freaking 10. 1.6. Nice. Okay. So look at the kendama. Are these that much different? No, but look at the standard deviation. 2.4. So there's a lot more variability in these kendama master video folks. But again, irrelevant. Would you find this kid, find the video reassuring or hard to watch? So low is reassuring, high is hard to watch. What did most people say? In the middle. And look at the standard deviations, about 3 points. So there's a lot of error in those graphs. Okay, so let's scroll down. I'm really excited to see what this says. Oh. Okay, so what we do is we look at this T table right here. This is my Z-score, but it's a T, because a T is a difference in two means. A Z-score is U compared to a population, okay? So my probability of being, it's 17%. Is that good? 17%? No, I mean that's a Z-score of 0.17. Think about it. 0.17. Where's that? It's not low. It's right close to the mean. What if the T is 0? It is the mean. The two means are exactly the same. Therefore, it's 0. So we get up to this one. This is the one that we thought was pretty close. That the error bars only overlap by half, and it's 1.3. Oh, what do we need? 1.996. So here's the actual probability of occurring by chance. It's about 18% likely to occur by chance. Not bad. If we add more subjects and there is something really there, that might actually hold to be statistically significant. This is not bad for the number of subjects that we have right now. However, is it different? What number should we see here if we're looking for something that is different? What percentage do we use as acceptable differences in psychology? 95%. So if this is, what's the opposite of 95%? 5%, the opposite side of the curve. So if this is less than 0.05, we go, yay! But if it's not, we go, oh. So you go back and say, yeah, just because we got nothing. Okay, so, no. Okay, done. Okay, so we got nothing. So this is the idea, is whenever you get a data set, you have to make the pie charts. If you have a very big continuous variable, you want to make your histograms because you want to look for data that doesn't fit, that doesn't work. And then then you run your analysis. Why write the hypotheses down first before you write your before you do your analysis? That's the question you're asking to run the hypothesis, to run your analysis. So once you write this down, and people always forget to do this, they start running the analysis right away. Once you write this down, you know exactly what test to do. Okay, so I'm going to ask a question. Does watching the video change, watching any video, change your rating? Okay, so I'm going to write the hypothesis. So what is my hypothesis that I have to write? Does just watching the video itself change it? So what question am I asking? The kendama videos we just watched. So I'm going to combine both groups together. Is there any difference between the kid fail and the kendama master? No. There's no difference between the two. Okay, because there's no difference between the two, I'm going to combine the groups. I'm going to ask a simple question. Is the change in kendama ability after watching any video, does that change your ability to think that you can do it? So what kind of test am I going to do? One sample t-test. Okay? So I'm going to go to analyze. There's no groups anymore. We're just comparing. Are the numbers the same as 0? Because if nothing changed between the first half of the survey and the bottom half of the survey, what should the hypothesis be? What should happen? It should be 0. Bring one sample t-test. What are my test variables? Ooh, it worked that time. Those 3. Okay? And what's my test value? See right down at the bottom it says test value. Notice no groups. It's just one group now. It should be 0. So if watching the videos changed you in some way, then we'll see a difference here. No. So I say no really quickly because I'm looking at my motivation change. Here's my T. Ooh, almost a motivation change. 1.4, we need to be 1.96. It's really nice. When you don't have as many subjects, sometimes you need like 2.3 or so to see differences, but we're at 1.4. We're not there yet. What about success change? .5, but it has to be 0.05. Oh. Wait a second. What do you notice though? If I could use this to scroll up, if I can, it could be cool. What do you notice? Is there more change? Is there a bigger difference when we add the prime in there? Yeah, when we add the prime seems to change the success more than without the prime. You see how I'm seeing this? So that means the prime is doing something, it's just not doing enough. That's why I think if we add more subjects, we should find this. So, we ain't got nothing. So how come when you do an experiment, you got nothing? It happens way more than finding something. Most research, you end up with nothing. What do you think could affect this? This is actually this is the reason I think. This is the reason I think we're getting what we're getting. Well, I think if I ask my students in 2 years, when were these super popular? Well, these were super popular in, let's see, my son in second, third, and fourth grade. He's in 6th grade now, 4 years ago. Where were y'all in 4 years ago? High school, most of you. No, high school kids aren't walking around with these, and if they are, they're being beat up on the playground. Okay? Or they're hiding in the science teacher's classroom, I had all those kids hanging in my classroom when I was a high school teacher. Well, yeah, I had a bunch of track athletes that wanted to hang out in my classroom. They walk in there, and all the kids are like playing Magic and NJROTC. And my cool track kids walk in and look around and go, no, and they walk out. But eventually, I brainwashed them to come into my classroom because we always had track videos playing. And so the track kids would sit on one side of my classroom and the nerds would sit on the other side. And I'd be walking back and forth between the groups because I represent both groups equally. Okay, nerds. Okay, I like nerds. Who I hang with. Okay, so this could be a problem. So is there a relationship between kendama usage and answer? So the last thing we're going to do, and then we can run away, have a wonderful spring break, is a correlation. We've done these before. Remember how to do these? And this is what we call fishing. Oop, not that one, sorry. Fishing. I love fishing. We're going to do what's called bivariate correlations. Bivariate correlation. So a bivariate correlation, okay, is I just take all my variables and do what? I dump them in there. I'm going to get rid of this one because it's empty. Now, timestamp is literally the subject identification number. So some people really like to make giant correlation matrices. Dude, there's a significant relation of timestamp and people's grade. It's when they filled out, it's a random generated subject ID number. So, yeah, you might as well start charting out lottery numbers. Okay. Scatter plots of random numbers, creating faces. Okay. Back in the old original Microsoft Excel, there was a rumor that if you made a scatter plot of 2 random number generator, that it would create a print of Bill Gates' face in dots. Well, back then in Excel 3, I think, if you went to a certain column in a certain row and you typed in a certain code, a flight simulator would appear. Yeah. And so we find when the internet was first online, about 97, 98, we actually found the reference to it, so we tried it on our computers, and it worked. It actually full-on flight simulator. And you wonder why Microsoft products are so big and clunky. Well, but they have there's a bunch of stuff in there that you'll never ever use and see, but like a flight simulator. Sorry, moving on. Run. Nope. Just run. It's going to be enough to look at to begin with. So when you say, whoa, it's not too bad, but what you see is, you see this giant chart, okay? And what this giant chart is this giant chart is calculating a very simple mathematical formula, okay? I'm going to write the formula for it up here in the hypothesis that it's testing. It's testing a very simple formula. The z-score on x, times the z-score on y x and y position divided by n, right? And then I'm just going to add this one little thing. It's the average cross products of z-scores. Think of x and y in a variable, access. What's your z-score on x? What's your z-score on y? Okay, and what it does, this little mathematical formula plots it like this. So what's the coordinates of this part of the graph? I'm pointing this part of the graph up here. What are all the values in here have to be? Here's y, here is x. They have to be positive on x and positive on y. So this is called the sleepy group. This is what I remember Mr. Peak. That's the sleepy quadrant. And then he said you have the two winky quadrants. Positive, negative, and negative, positive. Those are the winky quadrants. Mr. Peak's always weird. But anyway, he was great. He was like one of my favorite teachers of all time because he would just be like insane the entire time. And we found out he actually was insane. But that's not important. It was awesome. Okay, I trimmed my eyebrows because of him. He had those giant, like 3D eyebrows. And he's looking at you and he's like, hair's everywhere. And whoa. Okay, so let's think about this. A z-score represents your relative position on the mean. What would you be if you were 0, 0 on two z-scores? No, that means that if you are the mean of x, what is your likely value of y? The mean. So if you are in this quadrant, if you are high on a z-score of x, you're also on a high on a z-score of y. If you're down here, you're low on a z. So height and weight are positively correlated. So which means is that if you are above the average height, you're also likely to be above the average weight. If you're below the average height, you're also likely to be below the average weight. So they're positively correlated because if I connect all the dots, it forms a line that goes up. But what about a negative correlation? Yeah, so we can look at lifespan and height. Lifespan and height. If you're short, what's your lifespan? High. Okay? Okay, so, but as you get taller, what happens to your lifespan? It goes down. And the people that are super, super tall have very short lifespan. Actually, there's a study they did with dogs. Is that the bigger the dog, the less it lives. Like Great Danes only live 8 or 9 years. It is depressing because you get a good, these little stupid fluffy dogs like we have, 22, 23, 24 years, no problem. They get real weird though when they start getting that old. Our dogs, we don't know how old she is because she's a rescue, but she's starting to get weird. She's afraid of our little Google Home voice thing. Like if I ask her, I have it in our kitchen, hey Google, what's the weather today? Hey Google, what's the weather today?
Cloudy, with a forecasted high of 65 and a low of 47.
So if I do that in the kitchen, the little Google Home dot fights with this one, which is kind of funny. I've had them talking to each other before. But it's funny, but she goes, ha! And runs away. She's getting like weird. Okay, moving on. So let's think about this in terms of a statistic. Now we're starting to see results. How would you rate yourself playing with kendama? There's a positive relationship between how you rate yourself on playing with kendama. If I give you a kendama, are you going to play with it right now? Well, the positive relationship is 0.38. The probability of that occurring by chance, it's a very simple formula to do the probability, is 0.02, which means if you have a high score of playing with, know what a kendama is, if I give one to you, are you likely to play with it? The answer is yes. You're more likely to play with it, which is it's a Captain Obvious kind of thing to ask, but the statistics are showing, hey, that's affecting whether you're likely to play with it. That affects your motivation. What about after you watch the video? Is there a relationship? Well, it's 0.04. So if I ask you first, but then the relationship disappears after I watch it. So it does, something changes. There is a change in the way you say, if we use, would you rate yourself playing with a kendama, maybe we could say, if you know what a kendama is, maybe that's the people that are affected by this. Okay, so I'm going to look down. So after the video, guess what? There's no changes. Let's see if there's an effect of the prime. Now, there's no effect of the prime. There is a significant effect of change. So I'm actually, it's funny, I looked for the asterisks. So when you find an asterisk, the correlation is significant at the 0.05 level. But then they actually say it's significant at the 0.05 level. So look at this. 2 means 0.01. This is pretty close to 2 after 2. But look at this, whatever column this is. But we'll get there about this second. But, so the first column, remember, the first column is just, do you know what a kendama is? And there's a negative relationship. Would you play with this in front of people? Negative relationship. So the more you have, you played with one, after watching the videos, what happens to your change? The greater the change in the negative direction, the less likely you are to say, bring it on, I want to play with it right now. So, as opposed to maybe adding males and females, what should I try and add? People who know what a kendama is. Possibly. I don't know. So the nice thing about this is that this doesn't tell you exactly why. It just tells you that the relationship there is greater than is likely to occur by chance. We can't determine cause with correlations. Correlations are just relationships. Like Dr. McGreevy, what a wonderful instructor that we had, used to always say there's a very strong correlation between the length of your legs and the length of your pants. Right? Do they cause each other? Well, sort of. It's not a causal relationship. It's a correlational relationship, because if you have long legs, there's a higher probability you're going to have longer pants. But if it was a causal relationship, if I wanted to get taller, what would I do? Buy longer pants and I'd be taller. It's not a cause, but it does have, is there a causal relationship between pant length and height? What is the causal relationship? Style, yeah, your style. Because if you don't care, you wear whatever. It drives me nuts when I see people walking on the heels of their jeans. It's a major raging event for me. Because as a kid, I wore hand-me-downs. And I made my mom hem my pants so they wouldn't drag on the ground. Because I always had to wear my older brother's stuff, and he was taller than me, and I just sucked. But we always made the hem so she could take the hem out so I could lower them down as I started to grow. The problem with buying high-quality clothes is they last forever. So when you start looking at this relationship, then you start looking at some of the other variables. I'm just going to look back across prime here. Does prime seem to relate to anything? Well, let me scroll sideways. So. Here's one. If I were to look at kendamas now, would I be likely to be successful? That's a significant effect with prime. So what t-test should I do right now? I found a significant correlation in prime and after video watching. Paired sample t-test, because prime is two groups. So analyze, compare means, independent sample t-test. I'm just going to get rid of these. So basically, I just cast my line out. I went fishing. So I'm going to put all of these in here, just because I can. These are after watching the video. Oh well. So just because you find a significant relationship, does that mean you're going to find significant differences? No. Oh well. Great. Okay, so have they got anything to look at on Friday yet? Not yet. So I'm hopeful, scrolling all the way back up, I'm hopeful that this, okay, you guys will forget this by next week. If this null hypothesis is indeed incorrect, remember the null hypothesis, if this mean is not the same as this mean, if my alternate hypothesis is more pleasing, what should happen if I add more n? Which way? What I should see, if I add more n, what's the size of my error bar going to do? Shrink. If I add more n, what should the mean represent? The larger the n, the more the mean represents the average, the mu. So if I add more subjects, then maybe this will be true. It's not true right now because my n is small. What if I add more subjects and the error bars go boop and overlap completely? Then what is more likely to be true? The mu's are the same. So that's the reason why we add more subjects. If we add more subjects and there really is a difference in the real world, it will show up. But if there's not a real difference, when you add more subjects, it goes away. All right. Okay, so what is your only homework to do over break? Food. Food. Enter food into the database I sent out. There's a database. I'm looking for, find food that has value in it. For example, like I added 2 hard-boiled eggs and a bowl of oatmeal for breakfast this morning. A bowl of oatmeal cost me about 27 cents. Well, yeah, when you buy a big bucket of oats, it's pretty damn cheap to eat oatmeal. And then each egg, we buy organic extra large eggs, and they're about 25 cents each. So I had 50 cents worth of eggs, and I had 50 cents worth of oatmeal and blueberries. So my total breakfast cost me $1 and some change. Well, $3 for a bag of coffee that lasts about a week, so another 50 cents worth of coffee. So you can figure out the price of things if you bring them at home. I'm going to be adding a bunch of food that I get from home. We can look at the nutrition of Weinert family food compared to fast food, or compare. Please, somebody enter Wiener Schnitzel in. It's hilarious. The only time I've ever eaten there, our coach bought us what they're called hot dog sundaes, which is like a chili dog. It looks like a sundae, but it's made with chili dog. And then he made us run stairs afterwards. You don't get food poisoning, you just get sick. It's not food poisoning though. It's just bad.